Hello, back at it again. Here we are still with Learning Guide 3, and we are continuing on with the polynomial functions, and we are going to look at applying the remainder theorem. All right, so this is a little bit different from what we did just before this, because before we were trying to find the quotient, the q of x. So we're trying to find the quotient. In this case, no, it just wants us to find the remainder. Okay, so it's a little bit easier, or actually much easier. So watch. So what we do here is we take the opposite of our divisor. So in this case, we are taking the polynomial with a -4, and it's going in for every x. So -4 squared minus 10, take the x out, put -4, and plus 6. So if you type this into your calculator, you have a remainder that equals 62. So a lot easier than what we did before. Because this is, we're just trying to find the remainder. See, what is the remainder? Nothing to do with the quotient. So we don't need that. So here we take the polynomial, we take the opposite, so 3, plug it in. We don't even have to rearrange because we're just going to use our calculator. Plug this into your calculator, and the remainder here was -298. All right, so that's pretty easy, just to find the remainder. Now, we are going to use the remainder theorem to find k. So here we go. So we have the polynomial and we have the divisor, and up here we have the remainder. So how we set this up is we take the opposite of this and we put it in, so -1 cubed plus 2 -1 squared plus k negative, oops, it's supposed to be negative, sorry, -k minus 1 minus 1. Now, because when we enter all this in, out comes the remainder, which we know is 5. So 5 goes there. So what we are going to do now is just do some math. Take that, which is -1, square that first, so don't forget to square that first, which is +1, so that's 2. A negative times a negative is positive k, minus 1 equals 5. So now we're just going to collect these like terms, like terms, like terms. So we have k equals, because these all cancel out, right? Because that's +1, -1, 5. So there's our answer. So we found the value of k. So likewise here, we're going to put +2, because remember it's the opposite of sky. And then we have, whoops, keep the plus there, it's a minus k. And then 2 plus 3, and remember it equals the remainder. So in this question it's 5. And now we have 8 minus 4k plus 14 plus 3 equals 5. Now we have these like terms. So what do we have here? 17, we have 25 minus 4k equals 5. Move that over. So subtraction 25, right? Divide by -4, divide by -4. K equals 5. So that was a coincidence. And see how it all is 5. That is not true in all cases. So just remember, you're not going to get the k to equal the remainder. And in both cases, that was just pure coincidence. All right, so now we're going to look at the factor theorem. The factor theorem. Just remember, if you factor something, the remainder will equal 0. So very important. When you have a factor, the remainder is 0. So if I know that, all I need to do is do that remainder theorem I just showed you. And if we get a 0, we'll say yes. So let's try the first one here, A. So I'm putting in the opposite of that, so 1. And what's my output here? So we have 1 minus 3 minus 1 plus 3. Well, that is 0. So A is yes. Okay, that is a factor of that. And then you'd go through and try doing the same for all. Okay, let's move on to something a little bit more challenging. We are going to factor fully. Okay, so here we go. Factor fully is, just go back in time. If I said factor this, we could factor it no problem back in grade 9 and 10. So it's x and x plus 1 and plus 2. No problem. We could factor. However, now in grade 12, we have things with the cube there. So this factoring that we did in grade 9 and 10 and 11 is not so simple. So here we go. This is what we do. You take the last number, in this case it's positive 3, and you find all factors, or all products. Okay? I'll just say factors. So we have 1, we have 3, and they're plus or minus, remember that. So now we have to try each to find a remainder that equals 0. Okay, so here we go. So let's try the polynomial, and I'm going to try positive one first. Okay, so what do we get here? So that's 2, that's 1, that's minus 5, and oops, I forgot to put the 1 there. And that's minus 4 plus 3, and that does not get us a 0. All right, so let's try the next one, p negative 1. All right, so what do we get here? So we get negative 2, because remember that's this guy right here is negative 1. So that's positive 5, negative 5, that's positive 4, positive 3, that's 7, that's negative 7. Yes, we got it. Okay, so what I know from that is the first thing is that negative 1 I can use in my synthetic because it got a remainder of 0. So now I'm going to use my negative 1 with my synthetic. So I have a 2, a negative 5, a negative 4, and a 3. So remember that, just drop down times. So negative 2, that's negative, no, we add these, right? Negative 7, that is positive 7, that is positive 3, that times is negative 3, and we get a 0. So this is very important. You must get 0. Must get 0 remainder. R equals 0 here. If you don't, you did something wrong. So now, I'm running out of some space here. So let's put this together with our remainder. So the answer, I'll just go up here, is going to be x plus 1, because remember it's the opposite because it's divisor, and it's 2x squared minus 7x plus 3. Now before you say final answer, you have to check this guy, and it can factor. So the final answer, if you did your triple play or decomposition on this guy, the final answer should be this. All right. So you can just double check, do your triple play or synthetic. Okay, so this is very similar, so I'll let you guys try that one on your own. And the answer, hopefully, if you did it right, you should have gotten that. Okay. Now, these ones are slightly different now because we're missing terms. So we have to add in our zeros. But now we have to take this 27 and do those, finding the factors of 27. So we have 1, and we have 3, and we have 9. But it's going to be the 3. I'll give you a hint. Because if it's a cube, 3 times 3 times 3 equals 27. So that's a clue right there. That's going to be it. So we are going to use the polynomial of 3, or negative 3. And I'll give you a hint. If this is a plus, this becomes a minus. If you're over here, it's going to be positive because this is a minus. So there's a little hint. Okay, so let's plug it in. So we have, we know it's going to be a 0 because negative 3 cubed plus 27 gets us a 0, right? So now let's set it up. So we have negative 3, let's do a different color here, negative 3, and we have 1, and we're missing 2 terms, the squared term and the linear term, and then we have 27. So we drop times negative 3, add negative 3 times, and then add times negative 27, and I do the happy dance because look at that, I got a 0, which is very, very important. So here I have x squared minus 3x plus 9, and this guy just comes in as x plus 3. So this is your answer. Okay? And this would be very similar to the other one. All right.